Polygon. A polygon is a many-sided figure. It consists of it's a closed figure in a plane, blah blah blah, determined by 3 or more straight line segments. So you need at least 3 sides. Those straight line segments are called sides. So we'll use that information. And the sides made up vertices. Vertex is singular. A regular polygon has same length and same angle measures. These interior angles all have the same measure, so it means to be regular. And so they are named according to the number of sides that they have. So a lot of these you already know. If it has 3 sides, hey look, it's a triangle. Quadrilateral is a 4-sided figure. Hey, that's one such example. Pentagon is 5-sided. 1, 2, 3, 4, 5. A hexagon has 6 sides. 1, 2, 3, 4, 5, 6. Heptagon. Don't know if I can draw this or not. We'll try it. 1, 2, 3. What am I drawing? A heptagon? 7 sides? 1, 2, 3, 4, 5, 6, 7. I cheated. Who cares? That's how you do it. Octagon has 8 sides. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Something like that. Decagon, it has 10 sides. You can figure it out. Dodecagon has 12 sides. Some of these are easier to draw than others. You've seen them, hopefully, somewhere. But what we're going to do, we're going to look at the sum of the measures of the interior angles of an n-sided polygon. Anytime it says n, that just means the number of sides. So you find that as n minus 2 times 180 degrees. The reason why it's 180 degrees, that's the interior angle of a triangle. So let me start out with something before I do these examples for this to make some sense to you. So let's start out with a rectangle. If you know anything about rectangles, you have 4 right angles. So that means there's 4 90-degree angles. So anytime you see me use parentheses like that, that means multiplication. So 4 times 90 is 360 degrees. And that symbol means degrees. So if you add up all 4 angles of a rectangle, you get 360 degrees. Now what would happen if I were to take this rectangle and I cut it in half? Well, I missed it. I don't want to miss it. I want to make it better. So cut it in half by its diagonals. What I've done is I still have this 90-degree angle, but I've cut this in half, which means, so this one is 90. Let me make this a little bit bigger. Use a smaller pen. So I'm going to cut it in half. That one is 90. That one I cut in half, which makes that 45. And that one's 45 also. So you take 90 plus 45 plus 45. What do you get? 45 and 45 is 90. 90 plus 90 is 180 degrees. So that's for a triangle. So for a 4-sided figure, a 4-sided figure has 2 triangles in it. So let's try and draw a 5-sided figure, which is called a pentagon. So 1, 2, 3, 4, 5. So if I cut it this way and then cut it this way, how many triangles do you see? You see 1, 2, 3 triangles. Since I have 3 triangles and each triangle is 180 degrees, that's going to be 3 times 180, which is 540 degrees. Well, that's where this formula comes from. Everything about this formula is about a triangle. This n minus 2 is the number of triangles. And this 180 degrees is the triangle angle measure, if you were to add them up. It's the sum of the interior angles of a triangle. Yeah, you got that. I don't either. Probably should use a smaller size ink. So that's where this formula comes from. So if I use the formula, m minus 2 times 180 degrees. This n is this 5 right here. So it'll be 5 minus 2. I should put that in parentheses. Doesn't matter if the one of these in parentheses or not. Just to stay consistent, I'm going to leave that out. That parentheses. So it'll be 5 minus 2 times 180 degrees. And 5 minus 2 is 3. Which I've already done. I just shown you. I did the first time drawing the picture and cutting it up in triangles. Then the second time I did it, I just used the formula, which is way easier. Because some of these shapes are hard to draw. Like this 12-sided polygon, not about to draw, not about to cut it up. Because you know how many how many triangles it will have? It'll have 12 minus 2. So I'm just going to use the formula. n minus 2 times 180 degrees. N is 12. That's our n. So it'd be 12 minus 2 times 180 degrees. 12 minus 2 is 10. And 10 times 180 is 1800 degrees. Now, if this were a regular polygon, I could find the measure of each angle for either one of them. So if I want to find each angle measure, if regular, I just call it Pentagon. I'll have to do this one. I would just do this 540 degrees, and I would just divide it by 5. If that were a question, that may or may not be a question, because there's 5 angles, there's 5 sides, 5 angles, and so you divide that out, you get 108 degrees. Now, once again, never hurts to make sure. With the calculator, 540 divided by 5. So that could be a possible question. Don't know. So it's just a neat little formula to know. It all is about a triangle. All involves a triangle. Now the types of triangles, since we use triangles quite a bit, there's several types of triangles. One type is acute angle. That's all the angles are acute. What acute means is, easiest way to think of it, acute. Let me erase that because I want that to be a less than. It's less than 90 degrees. Obtuse, well, you already got the word obtuse there, greater than 90 degrees. So if you look at all these, do any of them look like they're 90 degrees or bigger? I don't think so. But now look at this one. This one, if that's a line, horizontal line, if I extend that upward, that's 90 degrees. However, that's not a line, or an angle, I mean. This is an angle. Like I said, this angle, this part would be 90 degrees. So this one is definitely greater than 90 degrees. So this is an obtuse triangle. This one is acute. All these would be less than 90. I only need one that's greater than 90 to be obtuse. So for acute, all angles are less than 90. And for obtuse, all, or at least one angle is greater than 90. And then for a right triangle, one angle is 90 degrees, like this one. This one has a 190 degree angle. You can't have more than one right triangle or more than one obtuse triangle, or let me go back. You can't have more than one right angle or more than one obtuse angle in a single triangle. If you do, it gets bigger than 180 degrees. Or equals 180 degrees in the case of a right triangle, but that's 180 is as big, is the largest sum of the interior angles of the triangle. So you can't go bigger than 90, more than one angle, 90 or bigger. It's too big. You can't have you don't have enough angles in to make a triangle. Now, some other definitions. These, let me go back. These three involve angles. Acute less than 90, obtuse greater than 90, right equals 90. These three involve sides. In the isosceles triangle, you got two sides are equal, so two equal sides. So anytime you see this, these double lines, that means these two angles or these two sides are equal. So I could put like a single line there to show that this line is different than these two. So it's got two equal sides, which means they have two equal angles also. Equilateral means all the sides are the same, which means all the angles are the same. So everything's equal in equilateral. Scaling, now I need to add some notation in this. Scaling, no two sides are equal, so I could put a line there, then a double line there, then a triple line there. What that means is none of these sides are the same, have the same length. So if you ever see that, that's what that means. So these are definitions once again. So let's review. Acute, obtuse, right is for angles. Acute is less than 90, obtuse is greater than 90, right is greater than is equal to 90, I should say. Then isosceles, equilateral, and scaling are sides. Isosceles have two equal sides, equilateral has three equal sides, scaling has no equal sides. So before we talk about more triangle information, we need to talk about the word ratio, because we need to talk about fractions, or proportions I mean. And when we get to proportions, then we start talking about similar triangles. So start with ratio. The word ratio is just a fraction. It's a fraction such that the top and the bottom have the same units. So if they don't have units, we don't have to worry about that. So we're going to write 2 to 3 as a ratio. And the way we're going to write that is just 2 over 3. And then 4 to 8, we're going to write that as 4 over 8. Hopefully you know how that reduces. Hopefully you know that 4 and 8 are both divisible by actually several numbers, but we're going to use the biggest, which is 4. So we're going to divide both 4 and 8 by 4. And 4 divided by 4 is 1. 8 divided by 4 is 2. So we always reduce our fraction down to 1/2 in this case. Now we have some units. 12 feet to 6 feet. So 12 feet on top and then 6 feet on the bottom. Now what happens here is these feet units cancel. There's 12 over 6. 12 and 6 are both divisible by 6. That is the largest such number. And 12 divided by 6 is 2. And 6 divided by 6 is 1. And depending on the system, it may want you to write it as just a plain old 2. Now this last example is interesting. We got to look at the units. So one unit or one ratio is 18 ounces over 3 pounds. However, these are not the same units, so we can't reduce the fraction quite yet. So we have to take into account that we know that 1 pound, well, don't want to use that. 1 pound, hopefully you know, is 16 ounces. And if you don't know, if you have to know it, it'll be given somewhere. So what that means is you have 18 ounces. Well, it's easier for me to work with the 3 pounds. So if 1 pound is 16 ounces, that means 2 pounds would be twice that, or 16 ounces more. And then 3 pounds would be 16 ounces more than that. Or I could just take 3 times 16. So 180 ounces is the same as, see, yeah, watch how you write these things. I put my 0 and my O together and it looked like I had two different things there. It's 18 ounces. I want the 0, the O with the Z, and not a 0 with the 8. So we got 18 ounces over 3 pounds. The 3 pounds is the same as 48 ounces. That's what I'm going to put on the bottom. And hopefully you know some things about fractions. You'll know once again that the units cancel, because that's what I want to happen. I want the units to cancel out. And I want to reduce this fraction. So we're at 18 over 48. And let's just say that you don't know what the largest number is that divides in both of them. Say you don't, but you recognize that 2 is. So let's just do a 2. And that may be the biggest. We'll find out. 18 divided by 2 is 9. 48 divided by 2 is 24. It just so happens that 2 wasn't the biggest because 9 and 24 reduces. Hopefully you'll recognize that 3 divides. 9 divided by 3 is 3, and 24 divided by 3 is 8. So the lowest that can reduce down to is 3 over 8. If you knew that 6 was the biggest, you could have bypassed an extra step here. 6 goes in 18 3 times, 6 goes in 48 8 times. But it doesn't matter as long as you find something. That divides into both. That's how you reduce fractions. Just to review, hopefully. So now we come to proportions. Proportion is a fraction equal to a fraction. This is a mathematical equation. We're going to solve these. The two ratios are equal. What that also means is the units correspond. And we're just going to do some basic solving equations. And the way we're going to do this is by cross multiplication. So what that means is you're going to take A times the D and then equals B times the C. I prefer to call it crisscross, or criss equals cross. Hey, hey, jump, jump. Criss equals cross. So we're going to go criss, which is x times 11, equals cross, 4 times 8. Once again, these parentheses mean multiplication, whereas this is multiplication. X times 11 is the same as 11x. I prefer to write it that way. It's easier to solve. Then 4 times 8 is 32. So that's our equation we're going to solve. And to solve this, we want to get the x by itself. To get the x by itself, you isolate the x by getting rid of the 11 that's been multiplied. That is 11 times x, so you divide both sides by 11. Yes, if you see a number with a letter and nothing in between, it's always multiplication. To get rid of the number in front that's being multiplied, you do the opposite of multiplication. It's actually the inverse, but we'll use the word opposite because it's easier to understand. You'll divide. To get rid of multiplication, use division. These 11s will cancel because that means they equal 1. And 1 over 1 is 1. 1 times x is x, which is what we want. That doesn't reduce. Leave it as a fraction in that form. Don't make it a mixed number. Let's come over here and do the same thing. Criss equals cross. Criss equals cross. Hey, hey, jump, jump. So I need to erase this because I don't know what that says. So we got 7 times x equals 15 times 8, or 8 times 15. It does not matter how you write it. You get the same answer either way. Once again, 7 times x, 15 times 8, or if you want to do 8 times 15 first, 7 times x on the other side, it does not matter. It's the same thing. 7 times x is 7x. 15 times 8 is 120, I hope. Yeah. Doesn't hurt to check. 15 times that symbol is multiplication. 8. 120. Never hurt to check. And then to solve this for x, once again, I'm going to get the x by itself. That's 7 times x. So I divide both sides by 7. That does not reduce. 7's cancel. Leaves x equals 120 over 7. And the reason why I did that is so we can answer some questions involving similar figures. We're going to focus on similar triangles. Now, what that means is the corresponding angles have the same measure, and the lengths to who cares? The corresponding sides are in proportion. What that means is the ratio of the corresponding sides are equal. So if I tell you that I'm going to use it, this is triangle notation. So if I tell you that triangle CBA is similar to the triangle FED, what that means is that if I were to take, well, first off, angle C would be equal to angle F. The angle measures would be angle B would be equal to angle E, and then the measure of angle A would be equal to the measure of angle D. I should be having like M's in front of those, the measure. If I've made other videos where I didn't do that, please forgive me. But that's kind of the best way to write it. I can also say this, which is what we're really going to focus on, the sides, the ratio of the sides. So this is side CB. And by the way, this here, so me use this symbol, that means similar to. That's squiggly. Squiggly means similar in mathematics. So if you ever see me write down CB, I probably should be writing it like this. And I can write that, but I don't want to write it like that because that could mess me up. But just know I'm looking at side CB over side BA of the first triangle. What that means is, if they're similar, the ratio of the corresponding sides are equal. So I come over here and look at the same two sides on this triangle. That's similar to that, correspond to it. So CB corresponds to FE, and BA corresponds to ED. So there's one possible proportion. There's several. There's actually three. I can do CB over CA too. So if I do that, it's going to be equal to FE over FD. CBCA, FE, FD. And then I can do, so I've done that and that, that and that. So now I'm going to do CA, or make sure I do that. I've done these. So I've got this side and this side, and then I have this side and this side. But I haven't done this side and this side yet. So let's do that. So we got CA over BA. That's equal to FD over ED. So make sure. So I got CB, CA. That's this one. I got CB and BA. That's this one. And I got CA and BA. That's this one. And correspond to the sides for this similar triangle. I could also use, you look at this notation and found these also. CB, BA, if you like CB, BA, FE, ED. Then I have BA, or I can do CA, BA, which is that one, FD, ED. Or I could have went CB, CA, FE, FD, which is this one. Yeah, probably easy to look at the picture. Probably confusing you right now. But just notice, I did this, I did one, the first one I did 1 and 2 and compared it with 3 and 4. How's that? Maybe that makes it a little bit easier. I don't know. Let's do some examples before I get you too confused. You're told these two figures are similar, so we need to find the missing sides. So here's what we're going to do. What that means is this side that has the angle that has 12 and 8, these sides correspond, and then these sides 21 and Y correspond, and 15 and X correspond. Now I can't use these two sides, two unknowns. So what I'm going to do is I'm going to use 12 over 21 on this triangle. And since these two sides are similar, two triangles are similar, since 12 over 21 is a ratio of this triangle, that means that 8 over Y is a corresponding ratio using the other triangle. And then now it's going to find Y, and then to find X I can do these two sides with these two sides. So I could do 12 over 15 equals 8 over X. Do you see that? Are you seeing what I'm doing? I couldn't use X and Y over here. There's too many unknowns, so I have to do it as two separate problems. I use this side for both of them because I know this measure and I know all three of those. So I'm using the ratio of corresponding sides and then using what's given. So I'm going to solve each of these equations by cross multiplying. That's the reason why I did the cross multiplication examples. So I'm going to do 12 times Y equals 21 times 8. 12 times Y is 12Y. 8 times 21 is 168. Once again, does not hurt to check. 21 times 8, 168. And then I'm going to solve this like I did previously. Using the same steps, going to divide. And then I'm going to reduce. So what divides the 168 and 12? Actually 12 does. So let's just try that. 168 divided by 12. It's probably going to be 100 or going to be 14. Yep. So y is 14. So I can actually label that up here if I want to. Let's do this one. So we got 12 over 15, so we're going to take 12 times x equals 15 times 8. I want to draw that a little bit better. Looks like a different symbol. So we got 12x. 8 times 15 is 120. I'm going to divide that, or solve that, using the same steps as before. Divide by 12. But I want my numbers looking like things that they're not supposed to look like. We get x is equal to 10. And if you take a good look at this, if you take 12 over 15 and reduce it down, how's 12 over 15 reduced down to? 3 goes in 12, and 3 goes in 15. And then 8 over 10, 2 goes in 8, and 2 goes into 10. When you reduce them down, you always get the same fraction. If you do corresponding sides, ratio of corresponding sides. Interesting, isn't it? It's just a little check. Don't have to do that. And so that's it for that type of a problem. Now here's a word problem. We're going to use similar triangles. Now what's going on here is you have a right triangle inside of another right triangle. What that means is these are similar triangles automatically. We have the same angle measures. And so it says Monique is going to remove a tree from a backyard, and she wants to know to hide the tree. So I'm just going to draw a line up through there. So this is a triangle, and you're told that the shadow of the tree is 45 feet long, so that's 45 feet. Monique is 6 feet tall, and her shadow is 9 feet long. So what you have this triangle inside of this big triangle. So if I were to draw that out to where you can see it. Big triangle. This is the tree. This is our unknown, so we're just going to call it x. Now the shadow of the tree is 45 feet. Then you get this small triangle, and this is Monique. And Monique is 6 feet tall, and her shadow is 9 feet tall. So what you have is, and by the way, this 45 feet goes all the way across. It goes all the way across. And the 9 feet is just this part right here. Well, if you take a good look, you got a big triangle. That's x and 45. Then you got a similar triangle. These are right angles, by the way. That's 6 and 9. And we're going to use these two triangles, one's inside the other, to find our equation, because these are similar triangles. So if you take x over 45, and x represents the height of the tree, the side that the ratio of the similar triangle that corresponds to x over 45 would be 6 over 9. And you saw that like we have been, cross multiplication. X times 9 equals 45 times 6. X times 9, same as 9x. 45 times 6 probably is 270. Once again, never hurt to check. 45 times 6. Yep, what do you know? And then to solve this, we divide both sides by what? 9. So x is equal to what? 30 feet. So the height of the tree is 30 feet. If you think about it, a 9-foot shadow is cast by a 6-foot tall person. A 45-foot shadow was cast by a tree. Well, the 45-foot shadow of the tree is 5 times more than the shadow of Monique's. If you take 5 times 6, you'll get the height of the tree also. So sometimes you can think about it and do it that way. But here's how you do it with similar triangles. And last thing we'll talk about is congruent figures. If you ever see me use this notation, that means congruent. Corresponding sides of similar figures, to be congruent, they have equal sides, they have equal angles. That's what that means. So all the angles are equal, all the sides are equal. So corresponding angles are the same measure, and corresponding sides have the same length. That's the main things to know about congruent. And so, let's look at this example. You're told these two triangles are congruent. And if you notice, one is labeled ABC. And the other one is labeled A prime, B prime, C prime. So if you ever see me use this word, it refers to that symbol, A prime. So you have triangle A prime, B prime, and C prime. So we're going to say these two triangles, or we're told these two triangles are congruent. Crazy things are happening right now. Crazy things. These two triangles are congruent. So that means is, if I write out everything I need to write out, is that measure of angle A, I probably need to be appropriate, is equal to measure of angle A prime. So the measure of angle B is equal to the measure of angle B prime. The measure of angle C is equal to the measure of angle C prime. Notice how I have this written out. It's written out based on the angles that they correspond to. A corresponds to A prime, B corresponds to B prime, C corresponds to C prime. I must write it correctly. And then you can say that side AB is going to be equal to side A prime, B prime. And then side AC is going to be equal to the measure of A prime, C prime. And then we got AB, AC, and that just leaves BC. That's going to be equal to B prime, C prime. If you think about it, it makes sense. Once you have it labeled correctly. So you're going by AB, A prime, B prime, AC, A prime, C prime, BC, B prime, C prime. So everything is right there for you. So now you go up here, and I could actually probably do everything, but I don't need to. So the length of AB, well, it's the same as A prime, B prime. Well, A prime, B prime is 100 or 12.5, so that means that is 12.5. That is not an angle. 12.5. That's it. Just got to see how they relate. And the measure of angle A, I don't know. A prime is what it equals. I don't know that one either. However, what do we know? We know that C is 117, and C is the same as C prime, so that's going to be 117. And we're told that B is 22 degrees, so what we have C prime is 117 degrees, B prime is 22 degrees. The reason why we know C prime is 117 is because C was 117 degrees. So when we add those two together, we get 139 degrees. What do we know about triangles? They equal 100, their interior angles, their measures equal 180 degrees. So when we subtract that off, 180 minus 139, what do we get? 41 degrees. That's what's left over. That's going to be our A prime. And we want the angle measure of angle A. So it's going to be equal to A. So that means that angle A is 41 degrees. The measure of angle A is 41 degrees. Did you catch that? Or I could easily recognize that that's 117, that B prime is 22, which means that B would be 22. And you could do 117 plus 22, and you'll get 139 that way. And then 180 minus 139 is 41 also. So it doesn't matter, just bring the angles over either way you want to go. I did it the long way just so you can see how everything relates. And if you want to make sure about what I did, it never hurts to take out a calculator. So I can take 117 plus 22, we get 139. So 180 minus 139, 41. So everything checks out. That's the answer. I think that's the last example. And it is.